There is a country that is being torn in two. Not by war, not by politics, by the planet itself. Beneath Iceland, two of the largest tectonic plates on Earth are pulling in opposite directions. One is drifting toward North America, the other toward Europe, and Iceland, sitting directly between them, is the only place on Earth where you can walk into the gap and touch both continents with your hands. The island was born from this tension. It is still being built by it. Every volcano, every glacier, every geyser and rift valley and lava field on Iceland exists because two sections of Earth's crust are slowly, relentlessly tearing apart and the planet's interior is pouring through the seam. This is Iceland. It is 16 million years old. It is one of the youngest landmasses on Earth. And right now, it is growing. To understand Iceland, you first need to understand what lies beneath almost all of the world's oceans, and what makes Iceland different from every other place on Earth. Running through the entire Atlantic Ocean, from the Arctic in the north to the Southern Ocean in the south, is the longest mountain range in the world. It is called the Mid-Atlantic Ridge. It is 25,000 miles long. Almost all of it lies hidden beneath kilometers of ocean water, where two tectonic plates are steadily pulling apart and magma rises to fill the gap, forming new oceanic crust in a process called seafloor spreading. Most of the ridge sits invisibly on the ocean floor. In one place, it does not. Around 60 million years ago, a second phenomenon coincided with the ridge in the North Atlantic, a mantle plume. A mantle plume is a column of superheated rock rising from deep within the Earth, far hotter than the surrounding mantle, pushing enormous volumes of magma upward. Where the Mid-Atlantic Ridge and this mantle plume intersected, the volume of magma was so extraordinary that the ocean floor was pushed above the surface of the sea. Iceland was born. It is the only place on Earth where a mid-ocean ridge is visible above sea level. It is the only inhabited island on the planet that sits directly on a tectonic plate boundary. And every feature of its landscape, every glacier, every waterfall, every steaming vent and volcanic crater exists because of that single geological coincidence 60 million years ago. The island is 103,000 square kilometers. It is younger than most mountain ranges. It is still being built. 45 minutes from Reykjavik, there is a national park called Þingvellir. The western cliff wall behind you is the edge of the North American plate. The eastern cliff wall in front of you is the edge of the Eurasian plate. The ground beneath your feet, the flat valley floor, is the space that has opened between them as they pulled apart over the last 10,000 years. That distance is approximately 70 meters. At 2 centimeters per year, that represents 3,500 years of planetary separation visible in a single walk. The valley floor is also sinking, subsiding by about 2 millimeters per year as the crust thins beneath it. In human time, this is invisible. In geological time, it is violent. The fissure that runs through Þingvellir also runs underground. It fills with glacial meltwater, water that filters through porous volcanic rock over a period of several decades before emerging into the fissure. This is the Silfra fissure, and it holds something extraordinary. The water that enters it is so perfectly filtered by the volcanic rock that it achieves a horizontal visibility of over 100 meters. It is the clearest water on Earth. Divers come from around the world to float between two tectonic plates in water so clear it appears not to exist. You can put one hand on the North American plate and one hand on the Eurasian plate. You are touching two continents simultaneously. No other place on this planet allows you to do that. Iceland has 130 volcanoes. At least 30 of them are considered active. It experiences more volcanic eruptions per square kilometer than almost anywhere else on Earth. This is not a hazard, it is a construction project. Every eruption that occurs in Iceland is the planet adding new material to the island. Lava cools and becomes rock. Rock accumulates over thousands of years. The island grows. The same process that built Iceland 16 million years ago is still running today. The same plates pulling apart, the same magma rising to fill the gap, the same new crust being laid down in slow geological time. Between 2023 and 2025, a series of 9 volcanic eruptions occurred along the Sunnukar crater row on the Reykjanes Peninsula in southwest Iceland. They were part of what geologists call a rifting episode, a period of increased activity as the crust tears and magma breaks through. The eruptions produced rivers of lava that flowed toward the fishing town of Grindavik. Roads were closed. Barriers were built. In some cases, lava crossed barriers anyway. And yet the eruptions were not catastrophic in the way most people imagine volcanism. They were not explosive. They did not throw ash to the stratosphere. They were what geologists call effusive. Lava simply poured from the ground like a slow burning river and began building new land. Iceland has about 130 volcanoes because it sits on the world's most productive magma source. The mantle plume beneath it produces twice as much volcanic material as the mid-Atlantic ridge alone would generate. This is why Iceland exists above the ocean at all. Without the plume, the ridge would be underwater, another invisible seam on the ocean floor. The plume is what pushed the island into the light. Iceland contains approximately 11% of all the glacial ice in Europe. It has more glaciers than any country on the continent outside of the polar regions. And those glaciers sit directly on top of active volcanoes. The largest glacier in Europe, Vatnajökull, covers an area of 7,700 square kilometers and reaches a depth of nearly 1 kilometer of ice in its thickest sections. Beneath it, several active volcanoes continue to erupt. In 1996, a subglacial eruption, an eruption that occurs under the ice, melted so much glacier from below that it generated one of the largest floods of the 20th century. The floodwaters carried boulders the size of houses across the Icelandic lowlands at speeds that destroyed bridges and swept cars out to sea. The event is called a jökullaup, an outburst flood from a glacially dammed lake. This is what ice and fire looks like when they share the same geology, not metaphor, not poetry. Ice sitting on top of active volcanic systems, each one waiting for the other to make a move. When Vatnajökull erupted in 2010, a name that most of the world spent weeks attempting to pronounce, it was a subglacial eruption that melted ice, sent meltwater flooding downward, and threw ash into the stratosphere. That ash cloud grounded 20% of all flights globally for 6 days. European airspace was closed for the first time since World War II, all of it from one small volcano in Iceland, a country of 370,000 people, disrupting global air travel for a week. Iceland is not remote. Iceland is central. Its geology connects directly to the rest of the planet, whether the rest of the planet notices or not. The same tectonic forces that tear Iceland apart also heat it. Over 90% of Icelandic homes are heated by geothermal energy, not solar panels, not wind turbines. The heat that comes directly from the Earth's interior, from the same magma system that feeds Iceland's volcanoes, is piped into homes, swimming pools, greenhouses, and municipal buildings across the entire country. Iceland is the only nation on Earth that meets the majority of its energy needs this way. Iceland generates essentially all of its electricity from renewable sources, hydro and geothermal combined. In a world debating how to decarbonize energy systems, Iceland is the answer to a question that most countries have barely started asking. What happens when you build a civilization on top of the Earth's most productive geological system? Iceland generates essentially all of its electricity from renewable sources, hydro and geothermal combined. In a world debating how to decarbonize energy systems, Iceland is the answer to a question that most countries have barely started asking. What happens when you build a civilization on top of the Earth's most productive geological system? The answer is, you never need to import fuel. You heat your homes from the planet's interior. And you swim in the byproduct of electricity production in the middle of a lava field. Iceland does not mine the Earth, it runs on it. Geologists call Iceland a natural laboratory. It is the only place on Earth where the process of oceanic crust formation, a process that has been building the seafloor for billions of years, is visible above the surface of the ocean. Every theory about how mid-ocean ridges work, every model of seafloor spreading, every understanding we have of how new planetary crust forms, all of it is tested and refined in Iceland, because Iceland is the only place where you can walk across the experiment. The mid-Atlantic ridge beneath Iceland has been pulling the North American and Eurasian plates apart for 60 million years. That process created the Atlantic Ocean. The same spreading that is currently adding 2 centimeters per year to Iceland's Rift Valley has, over geological time, moved North America and Europe from a position where they were almost touching to their current separation of 7,000 kilometers across the Atlantic. Iceland is the evidence that this happened. It is the scar of the Atlantic's formation, the physical mark left by 60 million years of a geological process that reshaped an entire ocean basin. And that process is still running. Right now, as you watch this video, the North American plate is moving one direction and the Eurasian plate is moving the other. Iceland is being pulled apart at the seam. New magma is rising to fill the gap. New crust is forming. New land is being added to the island. Land that does not yet have a name, that has never been touched, that has only just become part of the Earth's surface. We think of the planet as fixed. Iceland is the reminder that it is not. Iceland is 103,000 square kilometers of geological evidence. It is the only island on Earth born from the collision of a mid-ocean ridge and a mantle plume. The only inhabited place on the planet where you can walk between 2 continents. The only nation that heats its homes from the interior of the Earth. The only country whose border runs along a tectonic plate boundary, a border that, unlike most borders, is not fixed. Every year, Iceland grows slightly larger. Every year, the rift at Þingvellir is slightly wider. Every year, new lava enters the ocean at the Reykjanes Peninsula and becomes new land, land that did not exist the year before, that carries no name, that is simply the newest surface of the Earth. The ocean beneath the North Atlantic is young rock, younger the closer you get to the ridge, older the further you move toward the continents. Iceland sits at the exact point of zero age, the most recently formed piece of the Earth's outer shell, the newest geology on the planet. We stand on a planet that feels solid and permanent. Iceland is the proof that it is neither. The ground beneath it is moving. The continents around it are drifting. The ocean beside it is widening. The planet has been in motion since it formed. Iceland is simply the place where that motion is impossible to ignore. It is an island being born, and it is not finished yet.